Good evening. My name is Tim Fletcher, and I'm here to tell you about an engineering marvel and the site of an important ongoing scientific discovery. I'm here to talk to you about LIGO, the Laser Interferometer Gravitational Wave Observatory. LIGO was built in 1999 by a team of scientists and engineers from the California Institute of Technology and the Massachusetts Institute of Technology. It went into operation for the first time in 2001. There are two LIGO locations in the United States, one in Hanford, Washington, and the other in Livingston, Louisiana. They also work in collaboration with the Virgo facility in Italy, as well as with various telescopic observatories around the world. All of this so that scientists and engineers can search for gravitational waves that were predicted by Einstein's theory of general relativity in 1915. LIGO works by shooting a laser down two 4-kilometer-long vacuum tubes. The laser goes through a beam splitter and then bounces off of several mirrors to focus the beam and filter out any extraneous noise. The laser then reflects back to a detector. If the two lasers travel the exact same distance, the detector will not report any light reaching it. When a gravitational wave passes through the Earth, it causes the lengths of the arms to shorten or lengthen. This causes the lasers to be out of phase, and the detector will notice them. The LIGO facilities are some of the most intensely engineered instruments in the world. Their mission is to detect motion caused by some of the most cataclysmic and violent events in the known universe that happen millions and sometimes billions of light years away. This motion is 10,000 times smaller than the nucleus of an atom, making it the smallest measurement ever attempted by science. The instruments inside the vacuum tubes are so sensitive they can detect a change in distance 1/10,000th the width of a proton. To put that into perspective, that would be like measuring the distance to the nearest star, to within the width of a human hair. Because these instruments are so sensitive and that the measurements are so precise, they work in total vacuum. Inside the tubes, the air pressure is 1/trillionth of an atmosphere. In other words, it's 1/trillionth of what you would feel normally just standing outside at the beach. The tubes are so long and wide that it takes 40 days to pump out all the air and various gases that are inside. They are also long enough that when they were built, the engineers had to compensate for the curvature of the Earth. If they hadn't, the lasers would have been nearly a full meter above the reflecting mirrors at the end of the tunnels. All of this hard work came to fruition in September of 2015, when LIGO made its first detection of gravitational waves. These waves were caused by the collision of two black holes. They were about 30 times the mass of the Sun and roughly 1.3 billion light years away. On the left is a video of an artist's rendering of the collision and the waves that were given off by it. On the right is a short video and audio clip of a more recent discovery. In August of 2017, gravitational waves were discovered that were caused by the collision of two neutron stars. This was especially significant because scientists at the Fermi Observatory were able to see the gamma ray burst that was associated with the collision. This marked the first time that the cause of gravitational waves was able to be observed via the electromagnetic light spectrum. If you listen carefully, you can hear the short clip or chirp from the peak of the waves passing through the observatory. You might be thinking, this is all fascinating, but why is it important? Well, there are several reasons why this research is important. The discovery of gravitational waves validated predictions made by Einstein over 100 years ago. It also confirmed the presence of black holes in the universe. Until now, they were only subject to circumstantial evidence. Incidentally, black holes were another Einstein prediction. It is also possible that this research can aid in calculating the rate of expansion that our universe is experiencing. We may also discover more about the nature of neutron stars, as well as learn more about the birth and death of stars in general. I'll leave you with a quote from Edwin Hubble. "Equipped with his 5 senses, man explores the universe around him, and he calls the adventure science. LIGO is one more powerful tool to help us through that adventure." Thank you.